Hi everyone, this is a review for LO2 all about trigonometry. Okay, let's jump right into some questions. This is clearly a word problem. It says a cybersecurity team is setting up a surveillance drone, so something in the air, to monitor a data center. It's flying at a height of 15 meters, so let me draw the ground. And the height of this drone is 15 meters. And it says there's a camera on the drone that is angled at 35-degree angle of depression. Remember, when they say angle of depression, they are talking about going down from the horizontal. And so they're saying this angle is 35 degrees, the angle of depression. And how far horizontally is the drone from the specific point on the ground? Well, there's the point on the ground. The horizontal distance is this distance. We want to figure that distance out. Okay, so the first thing I want you to remember is that the angle of depression, this 35 degrees, is exactly equal to the angle of elevation here, 35 degrees, which is helpful for us because we like to do trigonometric ratios within a right triangle. So we've created ourselves a right triangle, and now we know one angle and one side, and we want to know the missing side. So first thing we'll do is relative to this angle, label the side. This is the opposite. This is the adjacent side. This is the hypotenuse. In this case, we're not really interested in that distance. We're interested in the adjacent side. So the trig relationship, which connects opposite and adjacent. I don't know if you remember this memory device. So, TOA, but opposite and adjacent would be tan. So I will start off and I will say that the tan of 35 is the opposite side, 15, over the adjacent side, x. And now it's simply an algebra problem to find x. So first thing I'll do is I'll multiply both sides of this equation by x. The x will cancel there, and we get that the x times tan 35 equals 15. And then we will divide both sides by tan 35. So I can isolate the x variable and solve for it. And on the left-hand side, when I isolate the variable, when I divide by tan 35 on top and bottom, that disappears, and we will get a final value of x equal to 21.4 meters. Let's see if that's one of the choices. Yes, it is. Okay, here where they ask for this question, which of the following is true? We can use the trig identities to replace things and see if we can get a true statement. So really the best strategy is to go one by one and see if we can get a true statement. Now I like to change everything into sines and cosines when possible. So instead of tan on top for this first expression, I will write sine over cosine. And instead of secant, I'll write 1 over cosine. And we are wondering if that's going to equal cosine of x. Well, if we have divide by cosine, that cancels, and this simplifies to be sine x, not cosine x. So we're going to say no for the first. Let's look at the next one. We've got cotan x, which is cosine x over sine. Tan, which is sine over cosine. And cosine, and we're wondering if that equals sine x. Well, let's cancel where we can. That cancels with that, and we're left with cosine x. So again, not quite what we wanted, so this one is not true. Now for these bottom two examples, we see a lot of sine squared, cotangent squared. It reminds me of the Pythagorean identities. So let me go ahead and pull those up from our formula sheet. Okay, you can see them on the bottom, and you can see that I could rearrange this identity. 1 minus sine squared x is entirely equivalent to cosine squared x on the top, And on the bottom, 1 plus cotangent squared x is cosecant squared x. Okay, we're wondering if that is cosine cubed. Well, leave the cosine squared x on the top. On the bottom, cosecant squared is 1 over the sine squared x. So in fact, this would be sine squared x cosine squared x, which no matter what we do, we can never make this equal to cosine cubed x. So we'll say no to that one. So let's hope the last one works. Let's see. 1 plus tangent squared x looks like this identity, that's secant squared x. 1 plus cotangent squared x is this identity again, which is cosecant squared x. If we turn this all into sines and cosines, this is 1 over cosine squared x on the top, and this is 1 over sine squared x on the bottom, which if you simplified this, that becomes sine squared x over cosine squared x, which in fact is equivalent to tangent squared x. Wow, finally we've got a match. So this does equal to this, and we've got our answer. Okay, here is a vocabulary matching question. Hopefully we can just go one by one. Let's look at the first one, angles in standard position. So we've got a coordinate plane and the standard position whose terminal side lies along an axis. So it's not in any one of the quadrants, it's along an axis. That's called a quadrantal angle. 2 positive angles whose sum is 90. So there's a right angle and you've got 2 angles adding up to 90. Those are called complementary. Okay. 2 positive angles whose sum is 180. So you've got 2 angles, they add up to 180. Those are called supplementary angles. Angles that measure exactly 180. So that would be the case where you've got an angle to there. That is called a straight angle. And now an angle that measures exactly 90 degrees, that's called a right angle. All right, angles that are less than 90, that's an angle that looks like this. It's called acute. Angles are between 90 and 180. That would look like this. That's called obtuse. And lastly, an angle that share the same side, same initial side, and same terminal side. So here's the initial side, terminal side. Whether it's this positive angle or this negative angle, those angles would be called coterminal. So that is C. Okay. Okay, now for this question, they've given us a point, and using that point, which is on the terminal side of an angle, we need to figure out sine, cosine, tan, cosecant, secant, and cotangent. Well, the first order of business is to determine whether this point, xy, is in fact on the unit circle. So the way you decide that is you see if it fits the relationship x squared plus y squared equal to 1. And it turns out when you plug everything in, yes, it is equal to 1, so this point is on the unit circle. So just as a reminder, when we're on the unit circle, that means the radius is 1, and any point on that unit circle, x, y, is talking about the horizontal distance and the vertical distance. And it turns out that using this reference angle, this being the adjacent side, this being the opposite side, and 1 being the hypotenuse, that the sine is just y, the cosine is just x, the tan is just y over x, and the cosecant is 1 over y, the secant is 1 over x, and the cotangent is x over y. And now that we know what all those values are, we can plug them in. So we get the sine of x is just the y value, which is negative 5 over 13, which is choice C. Cosine of x is just the x value of the point on the unit circle, which in this case is just 12 over 13, choice F. Tan of x is just y over x, so minus 5 over 13 over 12 over 13. This cancels and you get minus 5 over 12 for the tan of x, which is just choice B. Then we can quickly do the reciprocal functions. Cosecant is just the reciprocal of sine, so this is going to be negative 13 over 5. Remember, for the negatives, you can stick it on the top or the bottom or out in front of the middle. These are all equivalent places to put the minus sign. So minus 13 over 5 is choice D. Secant of x is 1 over x. It's the reciprocal of cosine, so it's going to be 13 over 12, which is choice A. And then the cotangent of x is the reciprocal of the tangent of x, so it's minus 12 over 5. Again, the minus can go on the top, on the bottom, or out in front of the middle of the ratio. So minus 12 over 5 is choice H. Okay, for this question, the instructions are to solve the right triangle, which really means find every piece of information that is missing. So what they gave us is one of the angles, 40 degrees, and they gave us one of the sides, 25 meters. Well, if they give us one of the angles, the other angle is quite easy to find. So let's actually, there is a typo here. I'm assuming that they want us to find beta, the other angle. So let's find that. And if alpha is 40 degrees, beta, the other acute angle, is just the complement, 90 minus 40 degrees, which is 50 degrees. So that would be choice G. Okay, let's look at the next question. Side A. So relative to the 40-degree angle, that's the opposite. We know the hypotenuse. So again, using our memory device, TOA, if we have the opposite and hypotenuse, we can use the sine ratio. We can say sine of 40 degrees is the opposite side A over the hypotenuse, which is C, which is 25. And then in order to solve for A, you just do a little bit of algebra. We'll multiply both sides by 25. And we'll get that A equals 25 times the sine of 40, which is 16.069 according to my calculator. 16.069 is about 0.07. And take a look. Of course, it should be smaller than the hypotenuse, which it is. So that answer makes sense. And then lastly, we need to find the missing side. You have two choices. You can use the Pythagorean theorem, or we can just use another trig ratio. Let's do that. Let's use the adjacent over hypotenuse. So we can say cosine of 40 is the adjacent B over the hypotenuse C, which is 25. And then we are just going to multiply both sides by 25. And so we should be able to get the value of B using our calculator. It's 25 times the cosine of 40. And we get a value 19.15 meters, which is choice A. Okay, here is an example where they give us the value of cotangent, and then they want us to find the value of secant. So it's really going to be something more complicated than a reciprocal function, because cotangent is the reciprocal of tangent, and that's not what they're asking for. And also cosecant is the reciprocal of sine, and that's not what they're asking for. So I have to think to myself, do I know any relationship that involves cotan and cosecant? Let me pull up the trig identities again, especially the Pythagorean identities, because we can see here a relationship with cotangent and cosecant. So let's use that relationship. 1 plus cotangent squared theta is cosecant squared theta, or x in this case. So we will say 1 plus cotangent squared. So 2.1 squared is going to equal cosecant squared. Okay, so we'll simplify the left-hand side, and we'll get 5.41 on the left is equal to cosecant squared theta. So if I would like to find out the value of cosecant, I can take the square root of both sides. Now usually it's plus or minus the square root, but in this case they told us we're in the first quadrant, and the first quadrant everything is positive. So we'll take the positive value of the square root of 541, and we get a decimal value of about 2. My calculator says 325. So really I would round it to 2.33. Sometimes we have errors like that, small errors. Just choose the closest, which is 2.32. Okay, here is a question that's talking about where different trig functions are positive or negative. Now, a very easy way to remember is we'll draw the 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And you might want to remember this little memory device where you say, all students take care. And what this will help us remember is that all of the trig functions are positive in quadrant 1, and the sine is positive in quadrant 2, and therefore it's reciprocal also. The cosecant is also positive. The tan is the one that is positive in quadrant 3, and also it's reciprocal, the cotangent. And then lastly, the cosine is positive in the 4th quadrant, and then also it's reciprocal, the secant function. So this is going to help us, but you can remember it by all students take care. Okay, so cosine of x, where is it negative? Well, it's negative. Remember, cosine, by the way, is the x value of points lying on the terminal side. So the x values are negative in quadrant 2 and quadrant 3. And then where is the cosecant positive? Well, the cosecant is positive in quadrant 1 and quadrant 2. So the question is, where does that all happen at the same time? That would be quadrant 2. So choice C. We'd say quadrant 2. Okay, let's look at sine. They're asking us in this next one, where is sine negative? Remember, sine is the y value, so we're talking about quadrant 3 and quadrant 4. And where is secant negative? Secant is related to cosine. So where are those negative? That's negative in quadrant 2 and quadrant 3. And so what do those have in common? Where does all of that happen at the same time? That would be in quadrant 3, which is choice B. Now let's look at tan. Where is the tan negative? Tan is negative in quadrant 2 and quadrant 4. Where is the cosecant negative? Cosecant is negative in quadrant 3 and quadrant 4. And so where does that all happen at the same time? Looks like quadrant 4, which is choice D. All right, one more, and we've got, where is the cosine positive? Remember, cosine is like the x value on the unit circle. Where is it positive? It's positive in quadrant 1 and quadrant 4. Where is the cotangent positive? Cotangent's related to tangent, and so those are positive in quadrant 1 and quadrant 3. So where does it all happen at the same time? Quadrant 1, which is choice A. Okay, here is a question about negative or trig functions of negative angles, and we actually have on the formula sheet a set of identities to do with negative angles. So let me pull that up. So I look at the identity for cosine, and it turns out that cosine is an even function, which means if you look at cosine on the left of the origin, the negative values for the inputs, it's going to be exactly the same as when you look at cosine on the right side of the origin, the positive value for the inputs for example, if I were to draw the cosine graph, it looks like this. It's a cup shape and it repeats itself. So if you go to the left, you go to the right, you're getting the same values whether you're dealing with negative x or positive x. So it turns out that cosine of negative x is 3/4. That's exactly the same as cosine of x. So cosine of x is 3/4. Now we're wanting to know about secant of x. Well, the secant of x is just 1 over the cosine of x. So it's just 1 over 3/4. In this case is 4/3. Okay, this is a matching question. And they're saying use the definition of trig ratios and the key circular points on the unit circle. Let me pull up that from the formula sheet. And let's remember that the sign on the unit circle, the sign of any angle on the unit circle, is equivalent to the y value. So let's find pi over 4. And there it is. So the y value for the point on the unit circle is square root of 2 over 2, which is choice J. Okay, now the cosine on the unit circle intersects at the x value. So let's find the cosine of pi over 6. That's 30 degrees. That's here. So we're asking for the x value at pi over 6, which is square root of 3 over 2, which is letter H. Okay, now tan can be represented by y over x, or sine over cosine, on the unit circle. So the tan of pi over 3, which is a 60-degree angle, is going to tell us to put the y value, which is square root of 3 over 2, square root of 3 over 2, and then divide it by the x value, which is 1/2. In the end, that will simplify and become just the square root of 3, which in our multiple choice is choice C. Now the cosecant is 1 over the sine, therefore it is 1 over y. And at the value pi, let's get rid of these, so at the value pi, we've got an angle that lands here, and the cosecant, so 1 over y, the y value, 1 over 0 is not allowed, so we call that undefined. The cosecant of pi is undefined, which is choice G. Okay, the secant of pi over 3, that's just 1 over cosine, so it's 1 over x at the value pi over 3, which is 60-degree angle, and the x value is 1/2. So 1 over 1/2 is just the value 2, choice D. And lastly, we've got the cotangent of pi over 3, which is just the reciprocal of the tangent, so it's x over y at pi over 3, which is 60 degrees also. And we've got our x value, 1/2, divided by our y value, square root of 3 over 2. If you want to easily simplify that in your calculator, it becomes 1 over the square root of 3, but if we rationalize it, we do not like square roots on the bottom. We get the square root of 3 over 3, which is what your calculator would have given you, which is choice F. Okay, and last but not least, we have the graph of a trigonometric function. Before I actually get into answering this question, I want to do a little reminder of the general shape of the 3 main trig functions we like to talk about. So the first one I'll say is sine. Sine starts at 0, 0 and makes an S shape. That is the general form of y equals sine x, and it will continue as the same wave forever in both directions. Okay, the cosine graph, on the other hand, starts at the topmost value, but it also will continue in both directions, repeating this wave pattern. But you can remember the difference because the sine curve kind of looks like an S, and the cosine curve looks like a cup, like you'd fill it with water and drink from it. So this is what the cosine curve looks like. And then tangent looks quite different. And the main reason is there are places where the tangent is undefined. So the tangent curve looks like this, and at pi over 2 and 3 pi over 2 and negative pi over 2, the graph itself is undefined. That would be the tangent graph. So those are the three you need to know. But now let's look at this particular question. It's definitely not a tangent graph. It's either sine or cosine because it looks like this wave pattern. And the way we can decide is we look at the point 0, 0. That is where the graph is starting, and it's making this S shape, so we know for sure this is a sine graph, not a cosine graph, not a tan graph. So I'm going to take their word for it that the exact equation, they didn't write y, they wrote f of x is sine of 2x. Now remember, that number that's in front of the angle, that only affects the period. And that's the very next question they ask about the period. The period is the horizontal distance that the wave needs to complete one cycle. And so in this case, we can look, this looks like pi over 2, and then pi, I know it's hard to see, 3 pi over 2, 2 pi. So it looks like it completes one full cycle every pi units, which is choice G. Okay, the domain of the sine graph. What they're asking is, what values am I allowed to put in for the angle? And it turns out that you can put any value between negative infinity and infinity, and there will be a point on the sine curve that corresponds with it. So every real number, that's another way they often write it. Every real number, we can write that as all real numbers. These all mean the same thing. Every real number is allowed to be used as an input in the sine function, so the domain is all real numbers. The range, on the other hand, has limits. Range is the output, what comes out when you type in sine of any angle. And it turns out that you will never get anything lower than -1, and you will never get any value higher than 1 when you have a regular sine graph with no coefficient out front. So you can see here on the graph itself, the lowest it goes is -1, the highest it goes is 1, and so the range is right here. It is choice J. Okay, good luck on your test.